All right. Example 4, we have a function f of x is equal to 4 minus x squared. And the first question is just asking, is this function invertible? And explain why or why not. Well, this one's easy enough to graph. So let's just go ahead and graph it. There's a little space over here. So let's create a little graph of this function. So here's an x-axis and a y-axis. Now, you could look at transformations with this one, right? So you could see that it's going to be flipped upside down and shifted up by 4, right? Or you could just plug in some values for x, and you'll see that if x is 0, right, you get 4, and then you also get it's equal to 0. F of x is equal to 0 for 2 and minus 2. Minus 2. So if we graph this function, it's just going to be this upside down parabola that goes through 0, 4, and negative 2, 0, and 2, 0. Okay, so that's just a quick and dirty sketch of this function. I'm going to call this y, the output y. So y is equal to f of x. So y is a function of x. All right, and you can see right away if I try to use the vertical line test, it's going to fail, right? So I'm going to say no, this function is not invertible because it does not pass the, and I say the vertical line, horizontal line, horizontal line test. All right, horizontal line. Right, line test. Okay, so remember the vertical line test tests if a function is a function, right? Test the graph if it's a function. And the horizontal line test tells us if a function is invertible. Okay, and in this case, if we use the horizontal line test, we can see that it intersects the graph at 2 different points, and so it cannot be cannot be invertible, right? Because we would have, these outputs occur at 2 different inputs. All right, so if not, which it's not, then restrict the domain to make the function invertible. All right, so we'll just split it in half. We're going to split the function down the middle along the y-axis, right? Because then if I do that, I can see that for the functions over here on the right, where x is positive, there's only one y for every x and one x for every y. So that would be invertible. Or I could take the other half and I could say I could make the that portion of the graph invertible for x less than 0. So either way would work. So, but I'm going to restrict the domain to x greater than or equal to 0, and that would make it invertible, and I can just ignore the left hand side of that curve. And so if I just look at this part, well, let's see, maybe I can just color over it. If I just look at this part of the graph and ignore everything else, that would be invertible. All right, so state the restricted domain and the range of f and the domain and range of f inverse. Okay, so I'm going to restrict the domain to x greater than or equal to 0, which then means f of x is less than or equal to 4, right? Because the maximum value is going to be 4, and then it's just going to go, it can go as far negative as we want. Because we're subtracting x squared, so the bigger we make x, the more negative it's going to become. So that is the domain and the range of f of x. All right. Now let's look at the domain and range of the inverse. So remember, we're swapping the input and the output. All right. So now the input to the inverse is y, right? So y has to be less than or equal to 4, right? And the range then So we're looking at the output of the inverse function, f inverse of y, and that has to be greater than or equal to 0. Okay, so we're just swapping domain and range, right? Essentially here, f inverse of y is x, right? So, and f of x is y, right? So we're just swapping the domain and range. So this is the domain and range of the f inverse here on the right hand side, and then over here on the left, that was our f. You can tell because obviously this says f and this says f inverse. All right. So I'll meet you in the next video for the next example.